Hello friends, good evening. So as we discussed from yesterday, we are continue the topic of data science interview questions. Okay, so first question for today is, what is linear regression? Okay, or you can consider this question as why we called it as a linear regression. Okay, so what do you think? In what manner you are going to answer this question? You have some time. You may respond in chat box. What is the linear regression, or why it is called a linear regression? Okay, so the answer of this question is like, linear regression algorithm is telling us about the linear relationship between dependent and independent variable. That's why it called the linear regression, right? We have linear relationship of dependent and independent data, right? In linear regression. That's why it is called as the linear regression. Okay. There we have, it is helping us to find out how the relationship of our variable, right? Is it good or is it bad, right? With the help of our parameters. What kind of parameter? Like it will telling us strength of our relationship. Is it the range of that strength is from -1 to +1, right? -1, that means negative linear relationship, but that is strong. Okay, +1 means, yeah, the relationship is at a positive form, and that is also a strong relationship between dependent and independent variable. So there are the next question could be, then what is the types of linear regression, right? Okay, so if we talk about the types of linear regression, you can tell me what are the types of linear regression and how we can differentiate those types. Okay, so there are two types of linear regression. First one is simple linear regression. Second one is the multiple linear regression. Okay, as we know, in a linear regression, we have dependent and independent variable. We have to follow the linear relationship between that variable. But how the types are different? Okay, how the types are different? Simple linear regression, that means when we have only one input variable, right? That means the simple linear regression. And multiple linear regression, that means when we have more than one, like 2, 3, 4 independent variable, then it will called a multiple linear regression, right? Means, for example, if we have in our data simple linear regression, okay, so this is our equation, y is equals to beta naught plus beta 1 x 1 plus c. Okay, So this is the equation for simple linear regression, right? But if you want the equation for multiple linear regression, the equation could be like this. Wait, beta 2 x2. So what do you understand from this equation? Beta, this is the equation for MLR, means multiple linear regression. Okay, so what do you understand from this equation? That means when we talk about the linear regression, here we have only one independent variable. Yeah, only one input variable we can consider. Okay, and here we have more than one input variable. That could be n. Okay, that the number is not fixed but more than one. So that is the multiple linear regression. These are the two types of linear regression. Okay, understood? Okay, now we can go with our next question. Today's next question. The question is like, are expected value and mean value different? Okay, I will type here question to better understanding. Are expected values and mean value different? Okay, the question is like, our expected value and mean value are different. Yeah, if you want, you will take 10 seconds of time and give me a response in the chat window. Okay, try to think and try to give me an answer of this question, and then I will help you. So if I go and if I try to explain this question's answer, what are the values, what are the expected value and the mean value? Is they are different, right? So answer of this question is like, they are not different. Okay, they are not different, but the terms are used in a different context, right? Actually, they are not different, but the terms are used in a context are different. Okay, mean is generally referred when talking about the probability distribution, right? Or a sample of population, right? Mean, we can talk about the mean in a probability distribution, right? Or a sample of population, where the expected value is generally referred to the random variable. Okay, now for sampling data, we can consider two terms. Okay, for sampling data, mean value is only the value that comes from a sample data, right? When we take a sample, we took mean of that sample, right? So that means the mean is only the value that is come from the sampling data. Expected value is the mean of all the mean, right? What we are doing, we're just taking a sample from our population, taking mean of that is the mean, that is the actual mean value. Okay, and if we take mean of all those mean, that is the expected value. Mean of all the mean, that means we are expecting some value in between this range, right? That is the expected value. Okay, for distribution purpose, mean value and expected value are the same. Okay, in a sampling data, mean of all the samples are different, and expected value means mean of all means. right? Means we are taking, for example, we have 100 of variables, our population data. From there we are taking 30 samples, right? So from that 30 samples we will calculate mean for each sample, that is the mean value for each sample, right? But if we calculate mean mean of all the mean, that means when we are calculating mean of each sample, first sample mean, second sample mean, third sample mean, and then we are taking that mean values and calculating mean of those mean values, that is the expected value. Okay, is it clear? Okay, now next question will be like, firstly I tell you, then I will write it down to understanding purpose. What does p value signify about the statistical data? What does p value signify about the statistical data? You will try to answer this question. You have time of 10 to 15 seconds. Try to respond in chat window. Okay. Okay. So p value is used to determine significance of the result. Is that is significant or not significant, right? It is helping us. It helps, the p value helps to read the draw, to read and draw the conclusion from a data. Okay. And it is always between 0 to 1. The range of p value is 0 to 1. Okay. It will telling us the significance level. Okay. Is that value is significant or not significant? Okay. So the threshold point is like 0.05. Okay. So in our hypothesis testing, we have null hypothesis and alternate hypothesis. Okay. So if the p value is greater than 0.05, p value is greater than 0.05, we cannot reject the null hypothesis, right? If the p value less than 0.05, if the p value less than 0.05, we'll be going to reject null hypothesis. Okay, null hypothesis means we are going to the making the assumptions, the condition. Okay, alternate hypothesis and null hypothesis. For example, there are two conditions. Okay, if the p value is going to high, the condition related to null hypothesis, it will going to be accepted. If the p value is less than, it will going to the rejected. Okay. In this manner, p value is using. The threshold of p value is like 0.05. We have to check is our p value greater than 0.05 or less than 0.05. Okay. And if p value is equal to 0.05, is the marginal value, indicates it is possible to go either way, right? It will go in anyway. Is it clear? Okay. Now, the next question is like, how can outlier values be treated? How can outliers values be treated? Okay. So, as we know, once we have data, we have to find out, is there any outlier? Because our mean is influenced by outlier. If we have outlier, the result what we are going to predict, it might affect. Okay, so we have to firstly find out outlier. There are various ways to find out outlier. Okay, with the help of graphs as well, you can find out the outlier. What is the graph? Box plot. With the help of a box plot or a whisker plot, you can say we can plot the outlier. Once we plot the box plot, and then we can see some of the value beyond the plot, that is the outlier. Okay, now we have found out the outlier, but how to treat that outlier, right? So if we have less number of outlier, like 2 3 or less number of outlier, that we can treat it manually. But sometimes the outlier value is more, right? The count of outlier is more, so to treat manually, it's not a good option, right? So there we have different techniques. Okay, we can calculate the range of our data and replace that outlier values with our range, right? That means when we have a data, okay, and there we have a range of our data, right? In outlier technique, in the box plot, we have 5th percentile and 95th percentile, right? We have to calculate the value of 5th percentile and 95th percentile. If any of the value from our data is goes beyond this range, so we have to replace the values with the 95th percentile. Okay, in this manner also we can treat outlier. One another way is treat outlier to remove those outlier, but that will not preferred. Okay, if we're going to remove the outlier, we are going to lose the data. Okay, and that we don't want, right? So these are some techniques to treat the outlier. One of like replace the values with the 95th percentile or 5th percentile, right? Or you have to remove those values. Okay, but removing the outlier is removing the values will not preferred. We are going to lose the data. And one more thing, uh, not all the values are outlier, right? Some of the extreme values, but those are not outlier. Okay, so we have to think about it before treating an outlier. Okay, but if you ask me the way how to treat it, we can replace with the 95 or a 5th percentile, and the second way is we have to remove. Okay, next question is like, what are the various steps involved in analytics project? Okay, we can go like, various steps involved in an analytics project or in an analytics, right? So the business analytics. Okay, you can think and tell me the steps in a chat window. There are 6 steps. Okay. So there are 6 steps of analytics. Okay. Or if you want to solve a business problem, there are 6 steps. The steps are like, firstly, business understanding. We have to understand the business and the problem. What is the problem a client having? Okay. For that, we have to understand the business. What kind of business he is having. Okay. The next step is like explore the data, become a familiar with data. Like we have to exploring a data set. Okay. Next step is preparing data for a model, data reprocessing. That means we have to detect outlier, create missing value, do transformation, do transforming variables like that. Okay. The third step is like data reprocessing, means data cleaning. Okay. After that, we can build a model on the clean data. That is the fourth step, like a model building. Okay. So we can apply different model on that data. We can check the value of the accuracy of that model, which of the model is going to suit for that data. If we have classification model, if we have to classify output variable, we have to classify in yes or no, true false format. So we have to choose a classification technique, or if our output variable is continuous, we have to do check a regression technique. Okay. In this manner, we can choose a model and build our model and that data set. Okay. The next step is like check the accuracy of our model. Okay. Validate the model using new data set. Checking the accuracy, that means, see, this model is working best for the data set you are having, but if you have a new data set, so what will be the accuracy of your model, right? So you have to check the accuracy for your model for a future data as well, right? Means generate some future data and check the quality of your model. And then the next step is like deploy your model. Okay, deployment of a model. What is the deployment? Means if we give code to our customer, it is not possible every time to run code and show the output, right? We have to give them some kind of a window, some kind of a web page, right? In that they can add their readings and get the output, right? So we have to deploy that model so they can be more connected to the customer, and he will be more understood, like how, in what manner he have to do. Okay. uh, this was the last step of our analytics project. We can deploy our model. This is the last step. Now the next question is like, how do we treat the missing values? In our data we are having missing values. How to treat them? There are various ways to treat a missing value. for that, firstly, we have to find out which type of data we are having, right? So there we have mean imputation, median imputation, mode imputation. Okay, so for that, firstly, we have to find out which type of data we are having. Is our data is continuous or we are having a binary data? Okay, that means we have the labels in our data. Okay, so if we have a continuous data, we can replace missing value with the mean. But the condition is like we have to check outlier first. Okay, we know our mean is influenced by outlier. So if we have outlier, we can't replace our missing values with the mean of the data. So for that reason, we are going to use a median imputation. Okay, if you are having outlier in a data, go with the median imputation. How to go? Firstly, just take that data, sort it, and then take a middlemost value and replace that value with the missing values. Okay. If you have a categorical data, replace your values with the most repeated value. That means the mode imputation, right? So there are three ways to treat a missing values: mean imputation, median imputation, mode imputation. If we have outliers, then go with the median imputation. If we don't have outlier, go with the mean imputation. If we have a categorical data, go with the mode imputation, right? That means we have to replace our mode most repeated value on the place of the missing values, right? So I think I have to go for a next question. And next question is like, what is the difference between skewed and uniform distribution? What is the difference between skewed and uniform distribution? Take some time, think about it, and let me know what is the difference between skewed and uniform distribution. Okay, so the difference between skewed and uniform distribution is like when the observations in a data set are spread equally across the range of distribution. When the observation of the data set means the data points can be spread equally across the range of distribution, then it is referred to as uniform distribution. Means when we plot our data, if we see the bell curve, that is the uniform distribution. There is no clear peak, right? In a uniform distribution, it will follow bell curve. Means the distribution of left hand side and right hand side will be the same. Okay. Then what is the skewed? Right now, distribution that have more observation on one side, right? It could be on left hand side and it could be on a right hand side. That is the skewed distribution. Okay, if we have more observation on the left hand side, that is the right skewed distribution. We can say it as a positive skewed distribution. If the maximum observation on the left hand side, we can take it as a negative skewed. Okay, we will take it as a left skewed distribution. Okay, so do you understand the difference between uniform distribution and skewed distribution? Uniform distribution means the variable are distributed on left hand side and right hand side equally. Distribution of variables are equal, right? In a skewed, we have majority of data on one side. If we have majority of data on a right hand side, then it will be left skewed. If we have majority of data on a left side, it will be right skewed. Okay, we will call it as a positive skewed or negative skewed. Okay. So the next question is like, what do you understand from or by? Okay, by recall and precision. Try to give answer. Think about it. What could be your answer? Okay, so the answer could be like, recalls measure of all the actual true samples. Out of all the actual true samples, how many did we classify as true? Okay, out of all actual true samples, how many did we classify as true? And precision means out of all the samples we classified as true. Out of all the samples we classified as true, how many are actually true? Understood the difference? See, the recalls mean out of all the samples, out of all true samples, how many did we classified as true? Okay, and the recall means out of all the sample we classified as true, how many are actually true? Okay, for example, we will see one example. See, for example, we have one couple and they have celebrated their 12th marriage anniversary, and suddenly the wife is asking to his husband, dear, tell me how many gifts or which of the gifts I have given to you for this 12 anniversaries. Okay, this is the question. So if he give out of 12, 10 times actual answer, correct answer, that means the 80%, that is recall. Okay, out of 12, if he tell all the 12 surprise correctly, then that is be a 1. Recall value will be a 1. Okay, that means he remember. Okay, he recall first time she gives me this surprise, second time she gives me this surprise, third time this surprise, and he will be just responding, okay, 12 times you have given me these surprises. Okay, so he is just classifying it correctly. That is the recall. What is the precision? If he gives 15 time answer, okay, 15 time answer of same question, but some changes in that answer, like okay, first time he classified 10 as a, okay, 10, you have 10 as a actual surprises. Okay, these are 10 true surprises you have given me. Okay, then next time he have explained, he have given some different number of surprises. Okay, these many surprises you have given. Okay, so what he is doing, he is just answering again and again 15 times. For example, 15 times he is answering the same question answer, right? Out of that 15 time, 10 time he given the true answer, okay, right answer, and 5 times he have given the wrong answer. Okay, that means 10 times he have predicted the actual surprises his wife is giving him. Okay, so that is the precision. Okay, that means if we are taking samples multiple times, we are giving answer multiple time, and then and then calculating how many times from that sample, two samples, we have calculated actual true. That is the precision. And recall, that means out of all the samples, how many are true. Okay, this is the difference between precision and recall. Now, next slide. What is common perception of a visualization? What is common perception of visualization? It's common perception of visualization. Okay, try to think it and let me know. Okay, see, people think visualization as just a chart and summary information, right? But they are beyond that. Okay, if we plot anything, if we plot a data, we can find out the underlying what is inside of that data, what is the type of data we are having. Like we have well distributed data, we have skewed data, we have peak data, right? That means we are getting information about our data with the help of a visualization, and with the help of that visualization we can take decision, we can take a decision of our data, right? Means if we plot, see, there are huge plots, like not only box plot, bar plot and all that plot, there are advanced plots as well. If we plot our data in those manner, we will find out some insight from that data. Okay, what we are having there, is there any outlier? If you are having missing values, how many are missing value, how our data is looking, right? So yeah, this is the way, this is the perception of the visualization. It is just not only a summary or just a charts. Okay, Now the next most important question. The question is like, why is data cleaning essential in data science? Okay. Why is data cleaning essential in a data science? Try to answer this question. This is the most important question. Okay. So see, when we are getting the data, we have the data from different sources. Okay, in that data we having null value, some of the outliers, variables are not proper. Okay, the data is not clean. Okay, so if we are going to work on that data, the system will going to take more time to estimate. And the major disadvantage is like, we can't clearly classify our output. Right? We can classify it, but not a true classification. Right? Means if we have there some of the data like null data, outlier, so our data is influenced by that. Okay, and as we know, whatever we are predicting on the existing data, if our existing data is not clean, so whatever we are going to predict, the accuracy is going to decrease, right? That is not accurate. So if we clean a data, it will increase accuracy of our model. It will delete redundancy of our data, right? It will treat missing values and all. And also it will estimate the time of computation. It will minimizing the computation time as well. That's why the cleaning of data is necessary. Right? Means if we are having a data set and that is not in a proper format. Okay, so if we are going to build a model on that data, it will not give us the true result. Okay, so for that reason we have to clean our data to increase accuracy of our model. Okay, to treat missing values, to treat outlier, so that we can get a true values in future prediction, right? In actual value, that means we can increase the accuracy of our data. Now the next question is like, what is k-means clustering and how to select k? What is k-means clustering and how to select number of k? Okay, k-means clustering is an unsupervised machine learning technique, a unsupervised clustering technique. Okay, in that we can make a cluster of a similar data. Okay, for example, if we take k is equals to 2, okay, so it will just try to build two cluster with a similar data set. Okay, it will merge the data, those are having maximum similarity in one cluster. One cluster, that means the data inside that cluster are more similar. Okay, now how to select K for the K-means clustering? Okay, in the K-means clustering, we have a elbow plot. Okay, in that elbow plot, we have to see the drop down values. The elbow plot is like on the x-axis, we are having number of clusters. Okay, and the y-axis, we have WCSS value. Within WCSS means within cluster sum of square. And x-axis, we have the number of cluster. Okay, if we plot, then we can get elbow like shape. Wherever we get the shape like our elbow, like sudden drop down of O value, that will be a best K value. Okay, that high value we have to choose for our further model building for the K-means clustering, and we can build a K-means clustering on that number of Ks. Okay, so K-means clustering is a unsupervised machine learning technique, unsupervised clustering technique. In that, we can take number of Ks with the help of elbow method, okay, elbow plot, and calculate mean of each of the data point to calculate similarity between the clusters, to calculate similarity between the data points and make a cluster of a similar data points, right? For example, if we have K is equals to 2, it will calculate the similarity. It will take two centroids, okay, and calculate distance of a data from each centroid. Whichever data point closest to the first centroid will be formed as a cluster 1. Whichever data points are closest to the second centroid will be formed as a second cluster. Okay, this is the K-means clustering. In this manner, K-means clustering is working. Okay. The next most important question is like, what are the difference between overfitting and underfitting? What are the difference between overfitting and underfitting? Think about it and let me know. Okay. So, overfitting and underfitting. When we are building a model, we are going to check the accuracy of our model. How to check accuracy? Which is our best fit model that is giving us the train data and test data. The accuracy of those both are nearly similar. That is the best fit model, right? But sometimes what happen, we will get train accuracy and test accuracy are different. Okay, means if we get train accuracy is high and test accuracy, sorry, if we get test accuracy is high and train accuracy is low, that means we are getting 90% of the train accuracy and only 30% of the test accuracy. The scenario is called overfitting. Underfitting means we are getting only 40% of train accuracy and 30% of test accuracy. Means the accuracy in test data and train data both is less. That is the underfitting. Okay. Overfitting means if we have if we run our model on a train data set, we can get a less accuracy. And if we run those model on test data set, we will get a better accuracy. Okay, this is the difference between the overfitting and underfitting, right? In terms of the bias and variance, underfitting means we have high bias, high variance. Sorry, low bias, low variance is our best fit model. High bias, high variance, that means the underfitting model. Low bias, high variance is the overfitting model. Getting it? Okay. Now next question is, what is cluster sampling? We know the sampling technique. So this is the question related to that. What is cluster? Yeah. Cluster sampling. Okay. So cluster sampling is a technique used when it becomes difficult to study the target population. Cluster sampling is a technique used when it is difficult to study a target population spread across the all area, and simple random sampling we cannot apply it. In that term we can use the cluster sampling. Okay, that means the population, the population, the area, the data set are huge, and we can't apply a random sampling there. In that way, we can, in this scenario, we can use the cluster sampling. Cluster sampling is the probability samples where each sample unit is a cluster of element. Okay, cluster sample is a probability of samples where each sampling unit is a cluster of a element, sample element. Okay, for example, researchers want to survey the academic performance of the high school student. Okay, uh, okay, for example, the school, they are considering the school from Japan. Okay, and they want to know the performance of high school students. Okay, he will divide entire population, that means entire data, entire population of Japan into different cluster. What are the clusters here? Cities, different cities. Okay, then the researcher select a number of cluster depending on his research through a sample or a systematic random sampling, right? So the clustering sampling is it is just taking each of the data points in a cluster, in a similarities, and then making assumption about that. Okay. Okay. So yeah, so these are the questions for today. Okay, tomorrow again we will start with the new questions. Okay, so yeah, if you don't understand anything, let me know in the chat window. I will explain it again. Okay, if there is nothing to do, nothing to ask, then thank you so much. We will meet tomorrow again. Till then, bye bye.